Hello.
Hey,
What's good?
Manachos, leches.
Si, senor. Vocab.
Unit
for the
3,
bonding.
Lecture 2, vocab for the bonding.
Let's do that.
Yes, 20
right
words coming your way.
Right.
Some might be very familiar.
First one.
Repeats.
Cation. Not cation.
Cation. What is it?
Cation. Meow.
It is an ion with a positive charge
Sure.
because it lost at least one electron.
Sure.
Don't forget it. You got to memorize it. Ask us to teach you again and again and again if you need it, but you've got to have that.
And remember that T can look like a plus sign, so it'll help us remember. And then the annoying one is anion, the exact opposite. Is a negative ion because it's gained an electron. Remember, electrons be negative.
Yipper.
Cool.
The octet rule is the underlying foundation of why atoms bond to each other to make compounds, because all atoms, except the noble gases, want a full valence shell of electrons, and valence shell of 8 is the octet, that's full is 8. So atoms are going to lose or gain or share electrons in order to get to having 8 in their outside shell. It's like a magic number.
The only exception is hydrogen, who is only going to have 2. We'll find helium doesn't do much bonding
at all.
It wants 2 too, but he's already got his 2.
So
we'll find hydrogen will have a duet. Everybody else wants that octet.
He said 2 too.
Mm-hmm.
The chemical bond, there are 3 types of chemical bonds.
There was.
They're formed by joining of 2 or more atoms together, resulting in stable electron configurations. All atoms that are involved in the chemical bond will achieve stability through the bonding, whether it's ionic, covalent, or metallic. That is why they do it.
Right. And stable is low energy. So lower energy. Energy is released to a lower energy. Lewis dots, we've done these already before.
We've done dots for elements, but we're now going to start combining those in actual pictures of molecules.
True. So this is a diagram that shows the bonding between atoms of a molecule or a compound.
And we're going to turn certain dots into solid lines showing an actual chemical bond.
There you go.
An ionic bond is when an atom gives away an electron to another atom. These 2 atoms now become ions. One's cation, one's anion. It's a complete transfer. And the electric charges stuck together in specific ratios.
Yep.
So you get ionic bonds, complete transfer of electrons.
Yeah, that transfer is the key word. Notice it's bolded and underlined.
Oh, yes.
This ionic charge balance. This is where I take the charges of the 2 ions, and I have to have enough so that they cancel out to be either a neutral compound or a polyatomic ion with a charge.
Right.
So the charge resulting from cations and anions canceling each other out, so to speak, pluses and minuses.
Polyatomic ions are scary, but they're simple. These reference table E shows us all the polyatomic ions that you need to care about this year.
When in doubt, check
it out. Right. You see NO3 nitrate, NO2 nitrite, or something like that.
Sure.
So these are groups of covalently bonded atoms that together carry a positive or negative charge. So poly means multiple, atomic, atoms with a charge, ion. So polyatomic ion, if you're understanding how your breakdown of your words is, tells you exactly what it is.
Sure. And then these guys are key for when you get that question of which of the following has 2 kinds of bonding. Because like you said, covalent bonding is what makes that polyatomic ion. But now it's an ion. So when it links up with another ion, now we got an ionic bond. So both bonds are present. If you get that question, you are looking for said polyatomic ion. Sharing of electrons is how we define a covalent bond.
Yep.
So sharing of electrons between 2 nonmetals, that's the other key, resulting in a stable electron configuration.
Yep.
If I need 2 and you got 2, well, maybe we can share them rather than me take them from you altogether.
Yeah, and we'll see all those details. A molecule is simple. It is not a compound. A molecule is actually non-metal elements. There's only 13 or something like that, covalently bonded together. That's why we show the lines and the dots in Lewis structures, and that's what we form when we make a molecule. That's all there is to it.
And then so a compound is basically a molecule that contains at least 2 different elements. You're going to find that we refer to compounds as ionics and molecules as covalents.
Right.
So compound you'll have to hold us to that.
It's kind of a tough thing because just like substance can mean anything, compound can mean either ionic or covalent.
It's like an
kind of
umbrella
is
term,
yeah.
generic.
So that's why we got to be asked to be specific if you are struggling.
Yes. Oxidation number. So this is that charge number in the upper right-hand corner.
Yep.
And this is the number assigned to an ion to represent how many electrons it's gained or lost, showing its current charge because of that.
Right. And it is stable as the ion because of the octet rule. So there it is. A polar molecule is a molecule that is out of balance. One side of the molecule's got more of the electrons, the other side of the molecule's got less. So it's not symmetrical. Asymmetrical, there's some geometry coming at you.
Yeah.
Uneven distribution of charge will make a molecule behave a little bit like a magnet, a north and south pole.
Yep.
And that is what we call polar molecules.
And when he's talking about charge, though, he's talking about the electron distribution.
Yes.
That's the all the negatives around it. Are they all on one side, or are they all evenly spaced?
Mm-hmm.
So in a nonpolar would be the opposite. And there's some examples here of nonpolars.
Yeah.
The
two, one on the bottom.
CL4.
Yeah.
So this is a symmetrical molecule with an even distribution of electrons. If you're listening and not bumping.
Yeah. Polar covalent bonds. So you can have polar molecules, nonpolar molecules. You can also have polar bonds and nonpolar bonds. So
Ooh, we got it.
within the molecule at large, the macro molecule, there's a micro bond. So you have to look at the bonds themselves to see if they're polar or nonpolar. Because even though you might have polar bonds in a molecule,
They can cancel each other
the
out.
shape of the overall molecule might cancel it out and make the molecule nonpolar.
Ooh,
So
yeah.
a nonpolar molecule may have polar bonds.
I'm hoping we've thoroughly confused you, and then we can unconfuse you as the unit goes.
Sure.
So nonpolar covalent bond is now going to be even. So we had symmetrical with nonpolar before, so that's the same. So now we evenly share our electrons. The best example of this is diatomics.
Right.
Right, because then the END has got to be zero, because it doesn't even matter what the electronegativity is of oxygen.
And
In O2, the numbers
END,
cancel.
just so you know, is electronegativity difference.
Yeah.
That's what we mean when we say END.
Yep.
Symmetrical, well, means the same on all sides.
It's almost like synonym.
Even distribution of charge, making opposite sides of the molecule mirror images. Boom, done.
There you go.
That's it.
Opposite, asymmetrical, which is uneven distribution of charge, leaving at least one side of the molecule different.
And if
Plus
that
or
one
minus.
side of the molecule has got an extremely electronegative element, the whole molecule is going to be asymmetrical and probably polar.
IMFs, we got a POGL on this bad boy that I actually kind of like. I like the polar bears and the penguins.
Yep.
Force of attraction between molecules themselves. Now, this is not a bond. This is, I've got a bonded molecule here, I got a bonded molecule here, and then, are you feeling me, bro? There's no actual bond between the molecules.
Right. They do interact, but that doesn't form a full covalent or ionic bond.
Correct.
Hydrogen bonding is the most important type of intermolecular force for introductory chemistry.
Sure.
It's where the hydrogen atom on one molecule is attracted to the nitrogen, oxygen, or fluorine atom on another molecule. Nitrogen, oxygen, and fluorine are the three most electronegative elements. They scavenge up electrons wherever they can possibly
They
get.
want them real bad.
And
mad, thirsty.
hydrogen doesn't have many really. It's basically just a positive proton hanging out on the end of a molecule. So that little positive proton gets attracted to the electrons of nitrogen, oxygen, or fluorine and forms this relatively strong intermolecular force that we call a hydrogen bond.
Right, and when he says relative, he's talking about compared to the other forms of intermolecular forces that they are. This one is the big bad boy on the block.
But it's still weaker than an actual covalent
Absolutely.
bond, which is even still weaker than an actual ionic bond,
True.
which is still even weaker than an actual metallic bond.
Wow, here we go.
So anyways, I
So
think
you mad smart.
I think
we done.
That's all. Hasta la vista, click the button. Yeah.